So if you see the same provision in lacing, so there how much we have increased the effective length of lacing column? Tell me how much we have increased? So it is 5%. So the lacing column effective length is increased by 5%. Here for batten column the effective length is increased by 10%. So if you see the example, so now first provision, effective length of batten column, effective length of batten column should be increased by 10%. If one end is fixed and other end is hinged, then what is L effective? L effective or KL? How much it is? 0.8 L. Agree or not? It is for single component. So if we use only channel as a column, then this is L effective. But if we use two channels and if those two channels so we are using two channels as a column and those two channels are connected by battens, then L effective in that case is, we should increase it by 10%, means we have to multiply with 1.1 into 0.8 L. So finally it comes out to be 0.88 L. So that is L effective. Agree? So this is the provision. Next. So take it out. Okay, the next. Now let us see the provisions regarding the dimensions of the bat. Provisions regarding dimensions. So obviously the dimensions here is width or depth. Okay, width or depth. So for D inter. So in the D inter. So what is meant by this? Effective depth of a intermediate batten. It should not be less than 3/4 of alpha or 2 into BF. So we know that what is alpha. So alpha is nothing but center to center distance between the components of the batten system. Okay, or components of the built up column. So that is, so out of these two, whichever is more, that is to be taken as a effective depth of the intermediate batten. So BF is nothing but width of the flange. Okay, width of the flange. So you can see in the cross sectional way, longitudinal way also. So width of the flange is BF. So the D inter should not be less than these two. It means out of these two, whichever is more, that we have to take as a depth of the intermediate batten. So after getting the effective depth of intermediate batten, to get the overall depth, what to do? We have to add 2 times the end distance. Okay, add the 2 times the end distance. Then we are going to get overall depth. Agree? Next. B end. So it should not be less than alpha or 2BF. So whichever is more. Out of these two, whichever is more, so alpha value and 2 twice the width of the flange value. So whichever is more, so that has to be taken as the effective depth of the end batten. So this is the provision regarding the depth, overall depth or width of the batten. Agree? Next provision regarding the thickness. So the thickness of the flat or batten is S by 50. So S is nothing but what is S? Center to center distance between the connections of the batten. So that is S. So the thickness of the batten should be equal to S by 50. So if you remember, what is the thickness of the lacing member? It is L by 40 for single lacing and L by 60 for double lacing. Agree or not? So between value 40, 50, 60, the between is 50. So for batten, the thickness is S by 50. So this is the thickness. So take it up. Okay, the next provision. So if we remember, in lacing system, to prevent the buckling of a component between the batten. So if you see here, this is the component. Okay, this is the component between the two battens. Agree or not? Now chances are there for these component to buckle like this. Agree or not? See here, chances are there for these the component between the battens to buckle like this. Agree or not? Buckle like this. Now to prevent this, we have to do one check or not. So what is the check we have discussed in the case of lacing system? What is the check? Tell me. Come on, recollect it. What is the check? Try to memorize it. What is the check? So the check is C by R minimum of component should not less than or should be always less than. Means you can say should not be greater than or should always less than 50 or 0.7 into slenderness ratio of whole column. Agree or not? So here also the same provision. So here also the same provision. C by R minimum of component should be not be greater than. It means it should be less than 50 or 0.7 of KL by R minimum of whole column. So KL by R minimum is the slenderness ratio. So for whole column. So first we have to calculate slenderness ratio of whole column and we have to multiply with 0.7. So we are going to get one value and 50. So out of these two, whichever is less. So that value we have to add up and this C by R minimum of individual component should be less than that. Then there occurs no buckling of the component between the battens. Agree? That is a provision. So take it down. Okay. Next, coming to the design. So if you again go to the lacing system, so how the lacing system is designed? So lacing system or members of the lacing system are designed by assuming them as the members of a truss. Yes or no? So based on that, we know that the property of truss. What is the property of truss? The members of truss are subjected to only axial forces, that is either tension or compression. Similarly, the members of the lacing system is also subjected to the axial forces, only force, that may be tension or compression. But here coming to the batten, so as they are straight, so now we are going to design the batten system or members of the batten system by assuming them as the members of frame. Clear? So battens are designed by assuming them as frame. Okay, frame members. So what are the members that are present in frame? Obviously beam and column. So now if you take beam, so beam is subjected to transverse shear or longitudinal shear, whatever it may be. So beam is subjected to shear force and bending moment. Agree or not? So it means the members of battens are subjected to longitudinal shear and bending moment, but the members of lacing system are subjected to only axial forces. How much force it is? V by n sin theta. So that much of force the members of lacing system is subjected to, but the members of batten along with the force it is subjected to moment also. The reason it is designed by assuming them as a frame members or members of a frame. But coming to the lacing, we have designed the lacing system or members of the lacing system by assuming them as a truss members. So why we have assumed as a truss member? So the reason behind that is we have provided lacing members as an incline. If some incline we have provided lacing member, but coming to the pattern, that is not the case. We are providing them as a straight. So that is why we have to design the batten members as a frame members and lacing members as the inclination is provided for lacing system. So we have to design the lacing system as a truss. Okay, members of a truss. So now this is the thing here. Next. Batten system are designed to resist a transverse shear force V. So how much? So batten system means here we are having two planes of batten. Here one plane and here one plane. So in this way we cannot see both the planes. Yes or no? So this is one plane and there occurs another plane opposite to it, which we cannot see in this diagram or in this view. So there exist two planes here in this diagram. Okay, in our example there exist two planes. So obviously those two planes are called as batten system. So this total batten system these total two planes of battens are subjected to a transverse shear force of V. So how much transverse shear force V? Any guess? So tell me in lacing system how much transverse shear force we have designed for? total AC system, how much the V is equal to? Their V is 2.5% of axial column load. Agree or not? Here also the same. So now V here is 2.5%, the same value. It means if we show here, this column is subjected to a load of P. Okay, column load of P. So now we have to design the batten system, total batten system for a force of transverse shear force of 2.5% of total axial load or column load. So P is nothing but factor design column load. So for this force we have to design batten system. So take it down. Okay, so now the total batten system is subjected to this force. Now individual member is subjected to how much force? So we know that members of batten system are designed by assuming them as a frame members. So we know that member of frame is subjected to shear and bending. So now from that we can say that these batten member or members of this batten are subjected to shear force and bending moment. Agree or not? Now let us see how much bending moment they are subjected to and how much shear force they are subjected to. Let us see. So first take it down. So I am going to rub this. Hope it is completed. Okay, so now let us see how much longitudinal shear force and bending moment these members of the battens are subjected to. Clear? So now the longitudinal shear force. SF. Okay. So now this member of batten is subjected to a longitudinal shear force of VC by NS. Agree. So this much of force each member of this batten is subjected to. So if you see here V, what is V? V is the total force on this batten system. How much it is? 2.5% of total column load. And then C, what is C? C is the spacing between the two battens. Okay. And then what is N? N here is the number of planes of batten. Agree. So how many planes are there here? If you see in this diagram, two planes. Agree. So here for connecting these two flanges, one plane and another two flanges, one plane. So here two planes of battens are there. So N is the number of planes of batten. Planes of batten. And what is S? So S here is spacing between the centroids. Okay, or you can say the distance between the centroids of the connections of a batten. Agree, that is S. So everything in this formula is known to us. Of course, we have discussed and it is clearly we have shown in the diagram. See here, the diagram is very important. Okay, so whenever you are taking this in your notes, so try to draw this very clearly. So diagram plays a major role. So if you understand this diagram clearly, just the rest of the concepts and rest of the projects are very simple to you. Clear? So now the members are subjected to this much of longitudinal shear force. And as we discussed that the battens we are going to design as members of the frame. So it is subjected to shear and bending moment also. Now bending moment in the column batten member of a batten, how much? Let us see. So bending moment. Bending moment. So which is equal to VC by 2N. So now each batten is subjected to this much of bending moment, which is equal to VC by 2N, and this much of transverse longitudinal shear force. Clear? So take it out. The member of batten is subjected to the shear force, longitudinal shear force of VC by NS and a bending moment of VC by 2N. So we know each and every term in this formula. VC, so and everything is known as. So take it out. Okay, so now this is about the built up column. So we have discussed in detail how to build a column. Okay, we can build a column by either by using lazy system or batten system. Agree? So we have discussed about the each and every system in detail and all the provisions regarding this. So this is about the built up column. So after this we will start doing the numericals so that you understand the total the concept, that is design of compression member. So with this the design of compression member is completed. So if we solve numericals like what you have done in the previous cases, so that you will understand these concepts with much clearly. Okay, with much clarity you will understand these concepts.